Okay, good morning everybody. Welcome back. 2 more weeks and we're done. It seems so nice. Gosh, it's 2021. Yay, 2020 is behind us. 1/4/21. Yay. God, I'm glad this year's done. So anyway, the objective. Today we're going to start trigonometry, okay? We're going to start right triangle trigonometry. Okay, so it sounds hard, but it can be really easy. It can be. So what I want to do before anything is let's draw ourselves a right triangle, okay? I'm going to do that. And of course I'm going to do this in our Zoom meeting as well, so we can understand how it works, okay? So before you get too far forward, right triangle. So it has to be a right triangle. So I'm going to put a little right angle here in my triangle, okay? There's my right triangle, okay? Now, what I have is 3 angles. The 90 degrees we already know, okay? This symbol here, this weird symbol here, it's the Greek symbol for theta, but what's just going to be our angle symbol. It's our angle. For us, when you see this symbol in its Greek letter theta, it's our symbol for angle, okay? So what I'm going to do is, since I already know that's 90, right, I'm going to put in then theta into one of these angles. I can put it either place, but for right now let's put theta here, okay? This is the angle I want to talk about. It's that angle there. Not this one yet, but I can switch it around. This angle here. So if I'm standing here on a right triangle, then I know that this side here is always called the hypotenuse, okay? The longest side, or the side opposite the 90, is always the hypotenuse. Okay, that's always going to be the case. Now, if I'm here, then the side opposite, would that be my opposite side, okay? So think about this as being a big triangular lake, and you're standing here and you throw a rock to the opposite side. So this would be my opposite side. And then this side here, since I'm standing here, is next to me, so that's my adjacent side. So this is super important for what I'm going to give you here, the ratios, okay? So here's my angle. All 3 sides have a name. This is the opposite side because it's the opposite side of my angle. This is my hypotenuse because it's always the side, the longest side, always opposite the 90. And this is the adjacent side because it's next to me. Okay, so here's my ratios. The sine ratio, okay, these are my ratios. Sine of theta is always equal to the opposite side over my hypotenuse. Okay, so it's always a ratio of this side over the side. And we're going to get some numbers to put the ratios together. Cosine is a ratio of this side, the adjacent side, over the hypotenuse. So it's going to be the adjacent side over the hypotenuse. Okay, and the tangent, which is what we're going to talk about mostly today, because most of our applications are tangent, is going to be our opposite side over our adjacent side. Okay, if we know that, then let's go ahead and use this. Now, before I move forward though, these are correct, okay? But, real quickly, think about this. What about this angle? If I instead said, because there's 2 angles, right, not the 90, that theta were here, that I was standing here at this angle, then that would make this side the opposite, right? Because it would be the opposite side. And it would make this side the adjacent, okay? Alright, so think about this. You have 2 angles. You can stand or be at either angle, or you could use either angle. So if I use this angle, then obviously this is its opposite side, and this is its adjacent. If you were at this angle, then that would be its opposite side, and that's be its adjacent, okay? Anyway, let's go ahead and take a look at this, okay? So from triangle ABC, write the trig ratios. The ratios, that's a fraction. The word ratio means fraction from A and B. So here's angle A, okay? Angle A, well, let's call that my theta for right now. If that's the case, then the 4 is my opposite side, right? I'll abbreviate. The 5 is definitely the hypotenuse because it's the biggest side. It's opposite 90, and I'll abbreviate hype for hypotenuse, and the 3 is my adjacent side. Okay, so let's go ahead and set up our ratios. Okay, so I'll slide this down. So let's do the sine of A. Okay, the sine of A is equal to the opposite side. Well, from A, that's going to be the 4 over the hypotenuse, which is 5. So it's just going to be opposite over hypotenuse, 4 over 5, okay? The cosine of A, because we're going to do the cosine of A, here's angle A. The cosine of A is going to be its adjacent over the hypotenuse. Its adjacent is 3 over the hypotenuse, which is 5. The tangent of A, tangent is equal to the opposite 4 over the adjacent, which is 3. Okay, now, because there are two angles here, let's take a look at the other angle. So let me erase my theta. Now let's talk about angle B, because I wanted angle A and angle B. So go to angle B, and there's my theta, my angle. Now that changes the names here. So what happens is, from angle B, this is its opposite side. And from angle B, this side is adjacent. Opposite, throw the rock to the opposite side. Adjacent means next to adjacent, okay? And now let's do the same thing. We're going to do the sine of B. Well, the sine is the opposite of the hypotenuse. So its opposite is 3. And its adjacent is, hypotenuse is 5. My bad. Opposite of hypotenuse. The cosine of B, okay, cosine of B, here's B. Cosine is the adjacent over the hypotenuse. Adjacent is 4 over the hypotenuse, which is 5, which is 4 over 5. And the tangent of B, tangent is the opposite of the adjacent, is going to be my 3 over my 4. Okay, if you notice this, it's kind of cool, but the sine of A is equal to the cosine of B. The cosine of A is always equal to the sine of B, and the tangent of A is always equal to the reciprocal of the tangent of B. Little things that you'll need to know in Algebra 2. Okay, moving the page over. Now, how do we use this, okay? Well, before we do anything, we got to check on our calculator, okay? So hopefully you have a good calculator. If you, even your phone will do it, but the phone isn't the best method for doing it, but your phone will. But you got to make sure before you do anything that if you find your mode button, you have got to be in degree mode, because these are degrees. Radians are something we're going to do in Algebra 2 and in pre-calculus, okay? So we're going to be in degree mode, okay? Got it. So now, and to check, try sine of 30, and you should get 0.5. If you don't get that, sine of 30, if you can't get this answer, then you should probably be talking to me, okay? We'll talk about this in our Zoom, okay? Make sure everybody can get that. So I did that. Hold on, I'll show you real quickly. Okay, quit. If I did sine of 30 for me, no, I didn't like that. Hold on. Oh, that's because I did it wrong. Sine of 30, there you go, 0.5. Okay, that's what you should get. Now moving on. Find the length of BC. Okay, here's BC. And BC is really my opposite side, right? So let's call it little a. Here's how we label angles. Angle A, side A. But it is my opposite side, isn't it? It's my opposite side from my angle. And the 12 is my adjacent side. Okay, let's figure this out. Here's my angle. Start your angle. BC is my opposite side. And 12 is my adjacent side. Okay, so we're going to set up tangent. So, look at my notes. What I I'm using is opposite adjacent, okay? Opposite adjacent has got to be tangent, okay? So let's set up tangent. So I'll set up tangent of theta equals my opposite over my adjacent. Okay, that's what my notes say. Okay, this is my opposite adjacent. Okay, I need to find BC, so I have to use the opposite side. I want to use my 12. I don't know anything about the hypotenuse, so forget the hypotenuse. I don't know anything about it, so we're not going to use the hypotenuse at all. Okay, so now theta is my angle, right? Theta is an angle. So I'm going to rewrite this as tangent of 36 degrees equals my opposite, which is BC, but I called it little a because I like a variable, over my adjacent, which is my 12. Use the 12, use the number, okay, 12. Now to solve for this, what I'm going to do is cross multiply, okay? I'm just going to multiply both sides by 12. Multiply this side by 12. Right? And then I'll have 12 times the tangent of 36 degrees equals A, which A, of course, is BC, right? A is equal to BC. All right, now I need to use my calculator. I'm going to put it in just exactly like that. So watch. I'm going to go 12 times my tangent of 36 degrees. Okay, my calculator is going to do the work for me. Hit enter, and I get about 8.7. Okay, and if you didn't get 8.7, then you better check your mode or how you put it in. But you should get BC, or A is 8.72. We'll round in nearest hundredth. Okay. All right, so we got BC using right triangle trig. Okay, now let me slide it up. Next example, find the length of GP. GP is this side. Okay, and again, I like to call it, if this is angle I, I'm going to call it little I, because the name of the sides are always equal to the name of the opposite angle. Okay, the sides, so that's angle I, little I. Okay, so GP is I. Again, let's look at my angle. Here's my angle. My angle is 42 degrees. My 15 is my opposite side. And my unknown, my GP, which we call little I, is my adjacent side. Okay, opposite because I throw the rock to the opposite side. Adjacent because it's next to it, and this already has a name called the hypotenuse. Okay, the hypotenuse is always opposite of 90. Okay, now from here, let's set it up. So I don't care about the hypotenuse. Hypotenuse is not important to me right now. I don't care about it. But what I do care about is finding the adjacent, and I'm going to use the opposite. So let's see, opposite adjacent. I'm going to use tangent again. Most of today's lesson deals with tangent. Okay, so let's set this up. So my notes tell me that I'm going to use tangent of theta. So I'm going to go tan of theta is equal to, well, my notes say opposite over adjacent, right? So that's going to be my opposite over my adjacent. Okay, so let's rewrite this because theta really is an angle. It's 42, so let's really write this as tangent of 42 degrees is equal to, because theta is 42, because it's my angle, and it's equal to the opposite, which is 15, over my adjacent side, which is my little I, or GP. Okay, now what am I going to do? Well, again, I'm going to cross multiply. So let's see, this one's going to take two steps. I'll show you why. Because if I cross multiply and bring up the I, multiply by I, then I have I times the tangent of 42 degrees is equal to 15. Okay, well, I'm not done yet. Again, I'm solving. So even this says tangent is I times it. So again, I'm just solving. So to solve for I, I'm going to divide by tangent of 42, because that's just a number in my calculator. I could do it, but I don't want to do it yet. But if I did my calculator, tan 42 is just a number, okay? It's just a number. So what I'm doing is just going to divide by tan of 42, divide by tan of 42 degrees, and then that's gone. So what is I equal to? Well, I can use my calculator, okay? So if I use my calculator, I go back to this. I put it in just like it says. I can go 15 divided by tan of 42. Put it in the calculator just like that, okay? And it'll do it for you. And I get an answer of about 16.66, okay? Approximately 16.66 and centimeters. Okay? All right, now, last example. Hey, how is right triangle trig used? Well, a lot. It's the most used math in our world. It really is. Not arithmetic, but math. Okay, so a 5-foot boy sights the top of a tree at an angle of elevation of 54 degrees. If he is 75 feet from the base of the tree, how tall is the tree? So let's draw a picture, okay? First of all, when I draw a tree, they do draw straight. I'm going to assume it's straight up and down. So I'm going to assume it's at 90 degrees. Here's my tree. I know, beautiful looking tree, huh? I can even make it green if you want. Here's my tree. Here's my tree. All right. And I got a boy. He's 75 feet from the base. Here's my 5-foot boy, okay? Now, he sights the top of the tree. Okay, that's going to be right there at an angle of 54 degrees. Now, the thing is that the sighting is from his eye. So the right triangle trig, the right triangle is suspended by 5 feet. Okay, so let's check that out. So here's his 54 degrees. The triangle I'm looking for is suspended. Okay, so it's up by 5 feet because the boy is looking at it from his eye. So there's my triangle. And 75 is there. And I want to find the height of the tree. So when I find the height of the tree, let's call that T for tree, I'm going to add 5 feet in because the triangle is suspended by 5 feet. Okay, so let's do it. So here's my angle. That's theta. What I want to find is the opposite side. And I'm going to use my adjacent side. Opposite adjacent, we should be familiar with that, is opposite adjacent is my tangent. So I'm going to set up my tangent of theta is equal to my opposite over my adjacent. So my notes say, okay? So theta is an angle, right? So I'm going to use 54. So I'm going to rewrite this as tangent of 54 is equal to the opposite, which is t. I don't know what it is. T over my adjacent, which is 75. Now, I know this 5. I got to add in the 5 at the end. So I'm going to add the 5 in. The plus 5 I'll add in the end. Okay, I'll add that in the end. Okay, so let's do this. Let's solve for t, which is from here to here. So I'll multiply by 75. And I'll multiply this side by 75. Okay, so then I'll have 75 times the tangent of 54 degrees is equal to t. Okay, so I'm just going to use my calculator again. Slide that up. I'm going to go 75 tangent of 54, and I get an answer of about 103.23. Okay, so then I get 103.23 is equal to t. And I'm almost done, except for the fact I need to add in this 5 feet because the triangle I found the from here to here is 103.23. So I add in 5 and I get 108.23 feet. There it is. Okay. So homework is out of your journal, and you need to get this done. If you have any questions, please call me, text me, whatever. Okay. There you go.